In this lesson, we're going to learn about the area of a circle and how it is calculated. Now, we're also going to look in the second part of the lesson on the next video clip. We're going to have a look at how sometimes parts of a circle are joined with other shapes to form what we call composite figures. And we'll also have a look at how to work out the areas of those shapes. But the first thing we need to remember is that, or at least learn, is that the area of a circle is calculated with this formula. Area is equal to pi times r squared. It's very, very important to notice that when you do this, the pi is not squared in the calculation. It's the radius of the circle that is squared. So there's your r squared there. So make sure that pi is not squared in that type of equation. And the other thing, of course, is to notice that the only piece of information you need to know about a circle to work out its area is its radius. So that's the only actual input that goes into it. And if a diameter is given, then all we need to do is to divide the diameter by 2 in order to calculate the radius so that it can go into the formula there. So watch out for questions that give the diameter, and we'll actually have a look at one of those questions in the next example, or the next two examples. So first of all, this one here that has got a radius given. Here's a circle. The main thing to remember is always to write the formula down when you start working. That's always a good part of the logic. From there, you fill in the information that you know. Now we want to find a. We can get pi from the calculator, and then the radius we read off here on the circle. So that's 7 squared. So using our calculators, we get a final value, in this case, of 153.9 centimetres. Now notice it's centimetres squared because it's area. Don't forget that. The other thing to remember is that it is rounded to one decimal place because pi is a number that continues on and on after the decimal point. And so we've rounded it. So let's put here that it's approximately equal to. That's what that symbol means. In this particular case, we've got a diameter given as 11. So in order to work out our radius, we need to divide that by 2. So we get our 11 diameter divided by 2, and a radius then of 5.5 centimetres is what we need to work with. So once again, we write our formula down. Always important to do that. Next, we fill in the details that we have. Now pi, once again, from the calculator, and the radius 5.5. And when we work this out, we get, once again, an approximate area because we're looking at one decimal place. So an approximate area of 95.0 centimetres squared. Now the reason why that's 0.0 is that it has rounded down from a number that looks like this. So if I wrote this out, well, you can actually check this out. I might leave you to do this. There must have been a number here that rounded down to give a 0 in the decimal place, the 10th position. So the 1/10th position or the 10th. Now in that case, this does indicate that it's gone to a accuracy level of one decimal place, so we don't drop the naught. We must still have it there. But there's our answer for the area of that circle. Finally, we're going to have a look at one example where we haven't got a full circle. In this case, we have a quarter of a circle. We can see that it's a quarter, but I want to show you what we need to write out when we do this. It says what fraction of a circle is drawn. I don't actually just want you to write down a quarter straight away, because if that wasn't a 90-degree angle in there, it would no longer be a quarter. So you need to know how to do this. So we could say that the fraction of the circle is equal to the degrees in the corner, or the angle of the sector, over how many possible degrees there are in a full revolution. Now, if you put this into your calculator, it does come down to 1/4 of a circle. But what I'm suggesting is if this was 30 degrees, for example, if it was 30 degrees, then we just put 30 over 360 and work that out as a fraction, and that would be then the fraction of the circle. So it doesn't matter what angle it is, just put it at the top over the full possible number of degrees, and you'd have your fraction when it's simplified down. But what we need to do now is to work out our solution for this one. We want the area of the whole part, so we want an area that is equal to 1/4 of a full circle. So in we go 1/4 of the area of a full circle is pi r squared. So we'll fill this out, 1/4 times pi. Now the radius here is 5.7 because that's the center of the circle and that's the circumference. So there's our radius, 5.7 centimeters squared. So our area is approximately equal to, in this case, 26 centimeters squared. And you'll notice that it's rounded to the nearest whole centimetre. So there we go, to the nearest whole centimetre. You can check this out. If you looked at it on your calculator, it would be something like 25.517, and it keeps going. So you can see that this one would cause 25 to round to 26 centimetres squared. Now in the next video clip, we'll have a look at using parts of a circle a little bit like this with other shapes to find what we call composite areas, including parts of a circle.